All right, morning, guys. So we're going to look at the that enrichment problem I posed on Thursday. No, on Wednesday afternoon. I was to go over it yesterday, but we got
I
caught
had
up
some
in
trouble.
going over some Khan Academy material with other
Hi.
students. So we're going to go over that today.
Morning, Dylan.
Good morning.
Morning, Dylan.
Good
This
morning.
session is being recorded, right?
Yes, it's being recorded right now. You are all being recorded.
Oh, okay.
Okay, so this is the problem, and if you didn't get a chance to look at it yet, take a moment and try to digest it. Hold on. Okay. Take a moment and try to digest it. Okay, so we have the situation where we have three circles, and I used the word here. There's a description, and I don't know if you're familiar with what this means. Okay, but the word here, it says that the three circles are tangent to one another. Do you know what that means?
No, not
Based on
really.
based on based on the
opposite.
based on the way that the diagram is drawn, what do you think it means? If the three circles are tangent to one another, just based on the way that it's drawn, what do you think it means?
You see him on the screen?
Anybody have any ideas?
You're right.
So for two things to be tangent to one another, what that implies is, okay, that the two objects are touching one another, and they're touching one another in a unique way. They're touching one another at one point and one point only. Okay, so let me just write that vocab word up. So tangent means to, it's an adjective, and it means to touch. It's touching at one point only. And you can see how this is applicable here, right? So all three circles are tangent to one another, and what that implies then is, okay, that the two circles will, you see the point that I'm highlighting there, right? So those two circles are touching each other, okay, at that one point. The two horizontal circles are touching each other at that common point. And then the two other circles on the right side there are touching each other at that common point there. They're touching each other at one point only. Okay, and that's what it means for two objects to be tangent to one another. All right. So with that said, okay, the task here is to find out what is the area of the shaded region here. So that region there, that's inside of that triangle, which is also in between all three circles. And I don't know about you, but when we find the area of things, right, then they always happen to be in the form of straight lines. Do you guys remember that, right? Like finding the area of a rectangle, that's just space times height. Finding the area of, let's say, a triangle, okay, it's 1/2 base times height, okay. The only time that we deal with anything that's not that's a polygon that's not a straight, that doesn't have any straight lines, okay, is a circle, okay. And the formula to find the area of a circle, right, as we've talked about in the past, that is pi r squared. We are going to need to use this. This is going to come in handy, okay, in the process of solving for this area here. So let's see how we can actually go about this. So we're going to keep this in mind, okay, as we go through this, as we go through solving this problem. So the area of a circle, okay, is pi r squared. And actually, while I'm writing the area of things, the area of a triangle okay, is 1/2 base times height, right? Where this guy is the base, and this guy right here is the height. Okay, so being that this is an enrichment problem, it is more likely that this problem will involve a ton of different other things, right? And you're right for thinking about that. Let's try to strategize, okay, how we can go about finding what that shaded region is. Does anyone have any strategies? Let's not even take into consideration of like what formulas to use, okay? But is there a way that we can find out what that shaded region is? Can anybody here maybe think of a strategy to go about that?
Yeah, find the area of the triangle and then subtract those 3 smaller parts of the circle from it.
I totally agree with that. So look, the strategy right now, okay, as Emmett pointed out, is we need to know the area of the entire triangle, right? That triangle that's in between the 3 circles there. And then if we can find out the area of that triangle and then figure out the area of these little like slices of pies here of the circle, okay, and subtract the area of the triangle by those areas, we can then end up with that area that's shaded in the middle there. So are we all clear with the strategy at this point? Right. So one more time, we need to find area of the triangle. Who's typing? So we need to find the area of the triangle. Okay, and then we're going to subtract that by the area of and there's a name for this instead of calling them like slices of the circle, right? A slice, I mean, it's not really like a technical term. The technical term here, okay, for the quote unquote slice of a circle, okay, is the sector. And I'm putting sector in quotations here because you didn't know what that was before. Okay, so area of the sector of the circle. So just to again define what that is, okay, a sector, okay, is the slice of the circle. Okay, and this will give us that shaded region if we go about solving for those areas and subtract them from one another. So which then brings us to the next logical process, right? So maybe perhaps it would be helpful to let's redraw the situation, maybe perhaps a little bigger. So I want to do that right now. So the triangle I have going on right now looks something like this. And this is not anything as exact as the diagram that I had drawn for you guys, okay? But it will do. There's another piece of information that's given, okay? What is the length of the radius of all the little circles there?
1.
It's 1, right? So therefore, what are the side lengths of this triangle that we're dealing with?
2, 2, and 2.
Yeah, and all the side lengths here must measure 2. So all of these things here must measure 2. So therefore, if all of these side lengths here measure 2, this is what kind of a triangle as a result?
Equilateral.
This must be equilateral. So all 3 of these angles, okay, are indeed congruent. They all measure 60. Wonderful. Okay, so in order for us to find the area of this triangle, remember this thing that I'm going to highlight right now, this was our strategy, remember? Okay, this is our strategy here. So if we're going to follow this strategy, okay, And if we were to follow if we were to apply the formulas that I've outlined at the beginning here, okay, how can I go about finding, well, what is the base of the equilateral triangle?
2.
What's the base is indeed 2. Does anyone have a strategy to figure out what is the height of this equilateral triangle? And as a matter of fact, okay, finding out what the height is here, it's been done before, or you've done it before, actually over remote learning, as well as at various points during our time together at school. Okay, so how do we go about finding out what that height is? I'm gonna draw. Yeah, go ahead.
We can use the sine.
I love that. We would use sine here. I love the fact that you are applying things that you've studied during remote learning. So Ty, since you brought up sine, do you know what is the angle over here that I'm highlighting right now?
That is the opposite angle of 2.
That is, well, hold on. I'm asking for what is the actual like physical angle? Like what is the number of that angle? Like what is the angle measure?
60.
That is 60 degrees. This is 60 degrees here. That is 60 degrees. Okay. And what is the length of this side length that I'm highlighting right now? Just that portion.
1.
That portion, that side length would be 1. So therefore this is 1. Okay, and we're looking for the height here. This is h. Okay. Well, wait a minute. If I draw this line, I drew this dashed line here, and that's labeled as h. Is h perpendicular to the base, or is it not?
It is
Yes.
perpendicular.
It
to
is. So
Why
therefore,
would we use the Pythagorean theorem?
we can, and we're going to end up in the same place. So h here, okay, is going to be perpendicular. So you know what? If that's the case, okay, Emmett, I want you to solve it using Pythagorean theorem. We're going to approach it using trigonometry because that was brought up during remote learning. Okay, Pythagorean theorem was what we had used during like physical school. So I want you to go ahead and try to figure that out while we go through it using trigonometry because that was applied, that was learned over remote learning. Okay, so h right now, is it opposite or adjacent to 60 degrees?
It is opposite.
It is indeed opposite. Okay, so h is opposite of 60 degrees. Okay, so are we going to use sine, cosine, or tangent?
We have to use either sine or tangent.
Sine or a tangent. I love that. Okay, just because sine involves opposite, and so does tangent.
Mm-hmm.
Cosine is the only one that doesn't. I love that. All right, so because of this, okay, Ty, because you brought it up, do you want to use sine or do you want to use tangent?
It's gonna be easier for you tangent because it's just 1. So let's just use tangent.
Okay, let's do that. So we can say tangent of 60 will equal to h over 1. Or anything over 1 is simply what?
H.
It's itself. That's right. So in other words, we know that h is equal to tangent of 60. Lovely. Okay. And if you punch that in, Ty, what do you get?
Okay. Tangent 60. Radical 3, which is if it's for a specific number, will 1.73.
1.73. 1.73. This comes out to be approximately 1.73. And I heard you say that this is actually h is actually equivalent to radical 3. And you know what? Tangent of 60 is indeed equal to radical 3. I love that. You did a really good job there. Emmett, did you also end up with radical 3?
Yes.
So h ends up equaling to some exact value, okay, having gone through this process. So we know that h is equal to radical 3, okay, having gone through all this. Wonderful. So if we know h is equal to radical 3, okay, what is the area of the overall equilateral triangle? How do we go about doing that now? I want to find the area of the equilateral triangle? Does anyone here know?
Yeah. Oh, you just do the base, 1/2 base times height. So you just do 2 times radical 3 divided by 2. So like the 2's cancel out and you just get radical 3.
So we end up with the area of the equilateral triangle, 1/2 times 2. That indeed does cancel out. We're left with area is equal to radical 3. So the area of the equilateral triangle also will equal to radical 3. Okay, so now I have half of the information that I need to solve this. What I just figured out right now, okay, is this part here that I'm highlighting. We just figured that out. We're going to now try to figure out the area of the sectors of those, or those slices, okay, of the circle. Okay, this concept of a sector, okay, has not been introduced to you yet, although with a little bit of logic, okay, each and every one of you here should be able to figure this out. So how can I figure out the area of the sector? What I'm going to do is I am going to draw a circle, and I'm going to try to recreate that highlighted area that's in pink. Okay, so I'm going to zoom in over here now. And the situation that we have is something that looks like this, where we have the so-called slice, right? And again, like I've said before, a slice is not a technical term. This is referred to as a sector. Okay, so this sector, okay, takes that shape there. Let's try to be a little more. Let's try to be a little more technical here, a little more exact. Michael, do you remember what is the angle here?
Angle theorem.
That is theta, but do you know what is the actual measure of that angle?
No.
We certainly do. I want you to think about it a little bit more. Kian, do you remember what that angle is?
Theta.
It is, well,
There's a value for theta.
60.
I'm calling that angle theta, but actually it has a physical number, and Emmett just said it.
60.
It is indeed 60, right? So that angle there is 60 degrees. So this angle is going to be 60 degrees. Okay? And the goal right now is to figure out what is the area of that shaded region. So how can we go about this? Okay? And I know that the radius, oh, what's the length of the radius one more time?
1.
It is 1. How can I find out the area of that sector? The process should not be any different from the way in which we found arc length, or at least in the very beginning of our introduction to arc length. Does anyone have any ideas on how we can find that physical area?
You find the area and then divide it by 6, since we know that 60 degrees in a circle is 360.
Yeah. So look, again, the process should not be any different from finding the arc length, because if you think about this, theta to 360, right? It should be proportional to the area of the sector and actually this concept is going to be reiterated next week, Monday that is, okay? So theta over 360 should equal to area of the sector over area of what?
360.
No, area of the how
Circle?
much?
Okay.
Circle.
Okay.
Right? Because 360 degrees is going all the way around, right? And theta is only a small portion of that, right? So therefore, that proportion should equal to the proportion of the area of the sector over the entire circle. This proportion must hold true, okay? So having this understanding now, okay, let's just try to place things in the correct corresponding places. What is theta at the moment here, Michael?
60.
So I have 60 over 360. And then I have is equal to area of the sector, okay, which I'm going to call that area there N. Okay, I want to call this area N.
Okay.
Okay, so it should be N over. Is Dylan still here?
Yeah, I'm here.
All right, Dylan. What is the area of the circle?
Uh,
So remember, the area of the circle is pi times r squared, right? So what's the area of the circle?
I don't know.
What's the radius of the circle, Dylan?
Of this circle, 1.
Yeah, it's 1. So what's 1
Oh.
squared?
1.
1.
1. And then pi times 1 is simply
3 point is pi.
it's pi. That's it. So the area of the circle is just pi. So again, I need to know what is the area of that sector there, right? So 60 over 360, that's 1/6, as Emmett said a moment ago, right? So therefore, n will equal to pi over 6. That's the area of one sector. That's the area of one sector. We're almost done. We're almost in the home stretch here, guys. Okay. So n is equal to pi over 6. Okay. That's the area of one sector. How many sectors do I have?
You have 3 sectors.
I have 3 sectors. So therefore, in order for me to accomplish this, okay, to do, because I was set out to figure out the stuff that I highlighted in yellow, right? What was the area of the triangle one more time?
Pi.
The triangle.
Oh.
Anybody?
Quiet, Michael.
Chris, do you
Michael.
remember?
Stop
Wait, what?
using the chat.
Oh
What
my
was-
God.
What was the area of the equilateral triangle?
Radical 3.
It is indeed radical 3. So it's radical 3. Oops. So radical 3 is the area of the equilateral triangle minus. Now I gotta subtract the areas of the sectors, right? And I have, as Ty said a moment ago, we have 3 of them. We have 3. Hi, what was the area of the sector one more time? Sectors.
60.
That was the central angle. But what was the
Oh.
area of the sector?
Oh, pi
That we
over,
found?
pi over 6.
Pi over 6. Love that. The area, as a result, okay, is radical 3 minus 3 pi over 6, or simply radical 3 minus 3 goes into 6 how many times?
1, 2.
2.
Twice. So my final answer, gentlemen, is simply this. This right here is the area of that shaded region. It's radical 3 minus pi over 2. Okay. So that is an exact answer. I mean, like there's no approximating there whatsoever. Okay. Your final answer for that shaded region, is that a rational number or an irrational number?
Irrational number.
That is an irrational number. Okay. Which is kind of expected because a circle, right, it's that rounded shape, right, where it's different from that of like a rectangle where you're just multiplying length and width, right? So even though the dimensions of the circle, okay, the radius was rational, the area, as it turns out, is irrational. Okay, there's no matter what you do, okay, if you try to get a numerical value out of this, like a decimal value out of this, okay, it will be an approximation. So this is the best answer you can possibly get, okay, for this problem. You guys have any questions for me regarding this enrichment problem?
Are there any more you put up?
Did I put up any additional ones yesterday?
No, I don't.
Is that what you asked?
Yeah, that was what I was asking. Yeah.
I did not put up an additional one since yesterday, no. But I will put up more in the this coming week. Okay. Do you guys have any questions regarding this?
I don't think so. No.
No.
I don't
Okay.
think so.
I'm gonna stop recording.